We were talking about collisions, right? We were talking about one-dimensional collisions. So I told you the classification of collisions. We can either have elastic or inelastic collision based on the value of E, or we can have um, or we can have uh, head-on or oblique collisions based on the direction of velocities and the line of impact. Yeah. I also told you that if along a particular line you find that, if along a particular axis you find that the external impulsive force is not zero, then you cannot conserve angular momentum. You cannot conserve linear momentum along that axis, about that axis. If, however, you find that the external impulsive force is zero, then there is no problem. Then you can conserve the linear momentum. Okay? So we derived a formula, right? V1 prime, V2 prime, which is used to find the velocities of objects after they have had a collision. Formula is applicable only under a strict set of circumstances. The formula is applicable if if along a particular axis there is no external impulsive force. I also told you that applying this formula is really going to be part of another question. That means that there will be a set of operations to do in a question in which this collision wala jo formula hai, that will be a part of the question. So we have done questions which rely only on the formula itself. We did a couple of those questions in the last class, but now I want to concentrate on questions which are going to involve collision, but they are going to involve other concepts as well. Okay. So question number 1 is, a point particle strikes a block of mass 7m horizontally. Find minimum P naught so that the upper block will topple. That means the upper block will fall to the ground. A E is equal to 1, B E is equal to half. भाई anyone? हाँ, इसमें कई सारे कॉन्सेप्ट्स एक साथ अप्लाई हो रहे हैं. So the first thing that you should ask yourself is, what is the condition that the upper block will topple? I mean, what does the question mean by this? What is the mathematical condition that the upper block will topple? What under what? नहीं 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 condition. No. N becomes 0 would not be a condition. हाँ बिल्कुल सही शान. नहीं, d distance नहीं 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 नहीं. Will your pen fall if you keep it completely off the table or नहीं? पार्ट फ्रिक्शन से कोई लेना देना नहीं. हाँ भाई, डी आएगा ना आंसर में, क्यों नहीं आएगा? और प्रतीक्षा, आप अपना पेन, when you keep your pen on the edge of the table, right? How should you keep your pen so that it does not fall? What is the condition? We keep.
सर हाफ से ज़्यादा अंदर की तरफ होना चाहिए.
So basically the condition is that the lower block should just, because of the impact from the point particle, there is no dependence on density. The lower block should just move a distance of d by 2. Right? HCV नहीं किया ना अभी भी. HCV में आई थिंक पहले ही क्वेश्चन है ना ये वाला. एक ब्लॉक के ऊपर एक ब्लॉक रखा ऐसे, एक ब्लॉक ऐसे रखा. So the question is, how many blocks can you stack like this? If the length of each block is L, they are identical to each other. The question was to find center of mass. When will this whole system topple? The whole system will topple when the center of mass. When the center of mass is beyond a certain point, right? So L by 10, ऐसा ही कुछ था, I don't remember. तो यहाँ पे भी, if the lower block, because of the impact, if the 7m block moves towards the right by a distance of d by 2, okay, then that should be it. This should be sufficient condition for the 3m wala block to topple, to fall down. Now remember, the 3m wala block is not going to move horizontally. Okay? There is no way that the 3m wala block can move horizontally because there is no external force on the 3m wala block along the x-axis. Right? फ्रिक्शन है नहीं उसके ऊपर, नीचे की तरफ mg लगा है, ऊपर की तरफ m लगा है, तो वो हॉरिजॉन्टली एक्सेलरेट नहीं करेगा. तो नीचे वाला ब्लॉक एक्सेलरेट करेगा because the friction between them is zero. When the lower block accelerates, lower block will simply shift by a distance of d by 2. I mean, that is a condition. So let's find out. M1 is equal to M, M2 is equal to 7M, V1 is equal to V0, V2 is equal to 0. I'm only interested in finding V2 prime if P is equal to 1. I'm only interested in finding V2 prime. So V2 prime will be equal to 1 plus E, 1 plus E M1 divided by M मतलब कौन सा,
M से जो नॉर्मल जा रहा है उससे वेट इंक्रीज नहीं होगा.
हाँ
3m से जो नॉर्मल है उसकी वजह से वेट इंक्रीज नहीं होगा.
क्यों नहीं होगा? तो उससे कोलिजन का क्या लेना देना?
तो मास 10m नहीं होगा.
नहीं नहीं नहीं, बिल्कुल नहीं होगा, बिल्कुल नहीं होगा. कोलिजन किस और किसके बीच में हुआ? कोलिजन किसके और
ऊपर वाला
किसके
म्यू
बीच?
जीरो नहीं होता तो फिर इफेक्ट करता.
हाँ, अगर ऊपर वाला म्यू जीरो नहीं होता, नहीं तब भी नहीं करता एक्चुअली, तब भी नहीं करता, क्योंकि ये जो नॉर्मल रिएक्शन है 3m और 7m के बीच में या 7m और फ्लोर के बीच में, ये इम्पल्सिव होएगा या नॉन इम्पल्सिव होएगा? इम्पल्सिव होएगा या नॉन इम्पल्सिव होएगा? Normal reaction between 3m, 7m and 7m and the floor will be impulsive or non-impulsive? हाँ निश बिल्कुल सही, it will be non-impulsive, right? और फर्क भी नहीं पड़ता अगर impulsive है non-impulsive है, क्योंकि हम तो x डायरेक्शन में बात कर रहे हैं. हाँ, अगर impulsive होता तो 7m और फ्लोर के बीच का फ्रिक्शन impulsive हो जाता, 7m और 3m के बीच का फ्रिक्शन impulsive हो जाता, तब फर्क पड़ता. माइनस नहीं आ सकता है, माइनस कहाँ से आएगा? अभी हम क्या कर रहे हैं? व्हाट आर वी डूइंग? वी आर जस्ट सेइंग दैट लुक, देयर इज अ कोलिजन हैपनिंग, कोलिजन बिटवीन m and 7m. Yeah, there is a collision happening between m and 7m. और मुझे कुछ नहीं दिखाई दे रहा है क्योंकि ये प्रॉब्लम के 3 स्टेजेस. Can you tell me the 3 stages of the problem? The 3 things that we are going to apply in the problem. Can you tell? The 3 things that we are going to. So the situation will evolve like this. First, there will be a collision between the point particle and the block of mass 7m. Because of this collision, the block of mass 7m will begin to move, will acquire a velocity. Because the block mass 7m will acquire a velocity, it will also be acted upon by friction, and ultimately this friction will stop the 7m wala block. Our exercise, our purpose is to arrange things in such a way that when friction ultimately stops the 7m wala block, it has traveled an exact distance of d by 2. Okay, this is the approach to this question. So V1 prime is equal to 1 plus EM1 upon M1 plus M2 into V1, और बाकी मुझे कोई मतलब नहीं है क्योंकि V1 प्राइम से मुझे कोई मतलब नहीं, V2 हमें 0 दिया ही हुआ है. So this will be equal to ये 2 और 8 कैंसिल हो जाएगा. This will be equal to V0 by 4. This is it. ये हमारा कोलिजन का कहानी खत्म हो गया. This is it. This कोलिजन का पर्पस केवल ये था, ये फाइंड करना. And once we have found this, once we have found the velocity of the block, right, then all we have to do now is say that, look, the initial velocity of the block after collision is plus V0 by 4. And by default, I'm taking this direction as positive. And the acceleration of the block now, this is the second hurdle that you have to face. First hurdle, collision वाला formula याद है कि नहीं? Second hurdle, can you tell me the acceleration? शौनक बिल्कुल ही गलत आंसर. Can you tell me the acceleration? आर्यन गलत आंसर. शिवेन गलत आंसर. शिवेन तुम्हें कुछ लग रहा है, एक चीज मिस कर दिया. हाँ शिवेन, ये सही आंसर. वेरी गुड बच्चा, वेरी गुड. नहीं अनीश, गलत आंसर. Please tell me the acceleration of the 7m वाला block. नहीं पार्थ, मेरे को acceleration बताओ पहले. तो आंसर तो आ ही जाएगा. acceleration बताओ. 7m वाले ब्लॉक का फ्रिक्शन की वजह से acceleration क्या होगा? नहीं पार्थ, 100 m भी तो आएगा ना उसमें. m नहीं, सॉरी m नहीं आएगा, बट 100 नहीं होएगा. नहीं 100 नहीं. अच्छा g का वैल्यू 10 रख दिया. नहीं नहीं, तब भी गलत. उल्टा कर दिया यार, देखो उल्टा कर दिया. हाँ अब सही. क्यों है ऐसा? So to find the acceleration, then all I have to do is find the acceleration. All I have to do is draw a free body diagram. So we have 7mg plus n1 n, and whatever the friction is, it is going to be mu n, right? So now n1 we know is 3mg from the upper wala block. N1 is equal to 3mg from the upper wala block. So n is equal to 10 mg. Mu n is equal to mu into 10 mg. Mu into 10 mg must be equal to ma. So A is equal to 10 by 7. आया सबको समझ में? अंडरस्टूड? तो भाई 7 ही तो शौनक मेन चीज है. So acceleration is equal to minus 10 by 7 g. Distance to be traveled is equal to d by 2. So V square is equal to U square plus 2AS. फाइनल वेलोसिटी 0 जाना चाहिए. V naught square by 16 minus twice A. So this means that V naught is equal to कितना आएगा? Can you tell me the second part? Please tell me the second part. हाँ अब सेम ही है बस. ये मेरा जो V naught by 4 आया है इनिशियल वेलोसिटी कुछ और आया, राइट? ठीक है. नेक्स्ट क्वेश्चन. So when the block of mass n collides with block of mass 2 n, E is equal to 1. But when it collides with the wall, E is equal to 2 by 3. हाँ, initially it is stationary. Initially 2m वाला block is stationary. I don't think this requires. Actually, the original question was that the 2m वाला block is not a block; it is a wedge. और वो wedge से slide down करता है m वाला block. But ठीक है, that would be बहुत लंबा हो जाता तो मैंने आपको छोटा कर. है। हाँ उधर ये पॉसिबल है। हाँ मतलब ये आंसर हो सकता है that any value of zero so after first collision E हाँ हो सकता है yes मैंने शायद मासेस की वैल्यू गलत दे दी है शायद।
सर अगर आप मासेस उसका m लेते उसका 2m लेते तो फिर वो कंडीशन बन सकती थी कोई।
हाँ एक्चुअली ओरिजिनल क्वेश्चन कुछ और बताया ना मैंने चेंज कर हाँ तो कहाँ पे थे हम लोग m1 is equal to m m2 is equal to 2m v1 is equal to v0 v2 is equal to 0 e is equal to 1 so v1 prime which will be m1 minus m2 sorry m1 minus em2 upon m1 plus m2 v0 v2 prime will be equal to 1 plus em1 upon m1 plus m2 v0. So v1 prime will be equal to minus v0 by 3 and v2 prime will be equal to 2 by 3 v0. हाँ
सही बात
गलत लिखा है क्या?
सर सही है।
सही है हाँ okay so basically what this means is that after the collision this guy is going to move on with a velocity of v0 by 3 this guy this guy will move with a velocity of v0 by 3 and this guy will move with a velocity of okay. Now second collision occurs with the wall so for the second collision m1 equal to m m2 equal to infinity हाँ any value हाँ V1 equal to V0 by 3, V2 is equal to 0, E is equal to 2 by 3. यहाँ पे मेरे को केवल V1 प्राइम चाहिए, मेरे को V2 प्राइम दीवार की वेलोसिटी से कोई मतलब नहीं, कोई लेना देना नहीं। V1 प्राइम will be equal to M1 minus EM2 on M1 plus M2, okay? तो ये M1 का कोई रोल ही नहीं है, so this is basically minus EV0 is equal to minus 2 by 3 into V0 by 3, which is equal to 2V1 by 3. Okay, now the collision would occur if this velocity was greater than this velocity, right, which is never going to happen for any value of V0, not going to happen. I could have rephrased the question. I can say find the ratio of masses such that this will happen. I can say that. Find the ratio of masses for which this will happen. But we don't, I don't want to do that. Okay. So this is all about one-dimensional head-on collision. Okay. One-dimensional head-on collision. If you go through HCV, you'll find that there are simple problems. A man is falling in the air. He has a briefcase in his hand, and he throws the briefcase horizontally. यहाँ पे all velocities, Pratiksha will give you the answer that only one collision is possible only. तो उसमें क्वेश्चन है कि वो आदमी ब्रीफकेस लेके हेलीकॉप्टर से गिर गया और अब उसको बचना है, तो उसने हॉरिजॉन्टली ब्रीफकेस को फेंका, राइट, पॉन्ड वाला, हाँ, ताकि वो पॉन्ड में गिर जाए. Then there is a question that there are two people A and B and they are throwing I think iron or very heavy spheres, sliding heavy spheres towards each other. So when A rolls the sphere, when A throws the sphere, when A throws the block, then of course A will also gain some velocity, the block will gain some velocity, there is no friction anywhere. And when B catches the block, then B will also have some velocity, and then B will throw the block, again there will be some change. So basically linear momentum का one dimensional या head-on collision का जो elastic हो या inelastic हो, you should be able to figure out very easily. I will give you, I think I'll give you one more question for this. So the question is that two particles attached to identical strings are kept as shown if they are released. E is equal to 1. Find maximum height of impulse after collision. नहीं नहीं नहीं, तरुण गलत आंसर है। शौनक गलत आंसर। मतलब तरुण एक आंसर गलत है, एक आंसर सही है। So the question is not very difficult. Again, at CV the question, I was hoping that you would have done it. Please do at CV. This will come down, this will come down. नहीं आ रहे मेरे पास. And there will be a collision here. इसकी velocity होएगी √2 GL और इसकी velocity होएगी √2 GL. So we'll write M1 is equal to M. नहीं इसमें गलत आंसर है. हाँ ये बिल्कुल सही. V1 is equal to √2 GL. M2 is equal to 2M. V2 is equal to minus √2 GL. So V1 prime is equal to M1 minus M2 upon M1 plus M2 into V1 plus. अरे एक आंसर गलत है, एक आंसर सही है. नहीं नीचे के लेवल से, यहाँ से ये जो ग्रीन और येलो एरो जो मैंने बनाई है. So this is equal to 2M2 on M1 plus M2 into V2. This will be equal to √2 GL तो कॉमन आ जाएगा. यहाँ पे आएगा -1/3 minus 4/3. कौन है भाई ये? आशुतोष क्या खा रहा है? This will be equal to -5/3. V2 prime will be equal to 2M1 by M1 plus M2 V1. नहीं अनीश, दोनों आंसर गलत है. प्लस M2 minus M1 upon M1 plus M2 into V2. This will be equal to √2 GL. 2/3 minus 1/3 is equal to √2 GL by 3, which I can write as √2 GL by 9. Right? अब बताओ. Now tell me the answer. Please tell me the answer. I have found the velocities after the collision. Please tell me the answer of the maximum height reached. We have had this discussion. In fact, our discussion has been very, very deep. शौनक, एक आंसर सही है, एक आंसर गलत. Find the answer. So if the we are talking about a particle on string, right? So V naught is less than root 2 GL. What happens? V naught is less than root 2 GL. What happens? V naught is less than root 2 GL. What happens? उसको नीचे बनाना चाहता हूँ. उसको याद है ना कि सब लोग भूल गए हैं. V naught is less than root 2 GL, then this happens. V naught is greater than root 2 GL but less than root 5 GL. What happens? V naught is greater than root 2 GL but less than root 5 GL. What happens? नहीं सोना गलत बोल रहा है ना. V naught is less than root 5 GL. नहीं 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 क्या हो गया. यही तो डिस्कशन किया था. Goes up to a certain point and then goes to a bigger. हाँ. V naught is greater than or equal to root 5 GL. What happens? नहीं शौनक तूने 180 डिग्री बोला. 180 डिग्री नहीं जाएगा. V naught is greater than root 5 GL. What happens? हाँ शौनक यही सोचा है. तूने लिख रहा है. अरे मेरा पेन. हाँ खोल सकते. अब मेरे को बताओ मैक्सिमम हाइट क्या होगा. ये मैंने क्या लगा दिया. मैक्सिमम हाइट क्या होगा. हाँ आप सही सही. सो नहीं नहीं बच्चा नहीं. क्या क्या हो गया है. इसका जो मैक्सिमम हाइट होएगा. इसका जो मैक्सिमम हाइट होएगा वो L/9 होएगा है ना. क्योंकि रूट 2 GH तक ही जाएगा ना वो. तो ये लेस देन रूट 2 GL है. तो इट विल बिहेव एग्जैक्ट particle inside a bowl or pendulum. तो जितना हम वेलोसिटी देंगे उतना ऊपर जाएगा. रूट 2 GH वेलोसिटी देंगे h ऊपर जाएगा provided that h is less than L. But this velocity is greater than root 5 GL. So this velocity is greater than root 5 GL. तो ये पार्टिकल जो है ये ऊपर तो जाएगा लेकिन बेचारा ऐसा तो नहीं है ना कि वो रस्सी को तोड़ते हुए ऊपर चला जाए. इसके लिए जो मैक्सिमम हाइट होएगी. इसके लिए जो मैक्सिमम हाइट होएगी वो 2L होएगी. राइट. उससे ज्यादा हो नहीं सकती है ना. The answer is 2L, L/9. You can't अंधाधुंध 25 L/9 नहीं लिख सकते. That is greater than 2L. ठीक है ना. इनफैक्ट अगर रूट 4 GL से वेलोसिटी ज्यादा हो गई तो आप एकदम सतर्क हो जाना चाहिए. रूट 2 GL से ज्यादा हो गई तो सतर्क हो जाना चाहिए बिल्कुल. नहीं तो फिर लोचा हो जाएगा. रूट 2 GL के बाद से मैक्सिमम वेलोसिटी मैक्सिमम हाइट निकालने का तरीका ही अलग होता है. नहीं बाद में प्रोजेक्टाइल शौनक ये नहीं बनेगा. ये गोल गोल घूमता रहेगा. चलो. So now we come to oblique collisions. Okay. अगर तुलिका मैं यहाँ पे वेलोसिटी √6 GL से इसको प्रोजेक्ट करूंगा तो ये क्या करेगा? √6 GL से अगर मैं इसको प्रोजेक्ट करूंगा तो ये क्या करेगा? What will it do? क्यों तुलिका? What will it do? बताओ भाई, what will it do? अगर मैंने इसको वेलोसिटी √6 GL दिया तो what will it do? आया समझ में तुलिका? What I'm trying to say, if you give it a velocity of √6 GL, then its path is exactly the right path. It cannot go. उससे ऊपर नहीं, उसके beyond कुछ नहीं है ना. If I give it a velocity of √6 GL, it is going to go in a circle. If I give it a velocity √16 GL, √160 GL, √1600 GL, any velocity greater than √5 GL, it is going to go in a circle. Of course, if I want the string to break, what I can tell you is that, look, the string breaks at so and so tension. So you can go to the topmost point, you can figure out the tension at the topmost point, and if it is exceeding the maximum value that I have given, then the string will break at the topmost point. Or in fact, it may break at any other point depending on that maximum value of tension. So as long as that is not given, as long as that is not in play, that the string may break, I can give it a velocity anything, right? 160 million GL ka root, it will still go in a circle, and therefore the maximum height to which it will rise will be 2. Cannot go beyond that. Cannot go beyond 2. Okay, so oblique collisions. Oblique collision का definition क्या है? What is the definition of oblique collision? Well, the definition of an oblique collision is a collision where the line of impact and the velocities of the objects are not along the same axis, are not along the same line. Okay. In this case, what you are going to do is we are going to consider and this is only in absence of external impulsive forces. So we are going to consider, in the absence of external impulsive forces, the collision of the particles or objects only along the line of impact. All velocities perpendicular to line of impact remain unchanged during collision. Okay, all velocities perpendicular to the line of impact, they remain unchanged. तो एक पार्टिकल का वेलोसिटी along the line of impact something and perpendicular to the line of impact is something, then the velocity along the line of impact will change due to the collision. Perpendicular wala will remain as it is. Okay. So E is equal to V2 prime minus V1 prime upon V1 minus V2 जो भी था, is now equal to the component of velocity of separation along the line of impact divided by the component of velocity of approach along the line of impact. Okay. Let's try this. Yeah, सबको समझ में, this is actually very easy. Just like when I began with projectile motion, I told you that look, up till now you have been learning about motion and equations of motion along one dimension. So here comes projectile motion, which is the same thing, same phenomena, everything remains the same except for the fact that now you have to apply the same equations of motion that you have been studying twice for the same particle, right? One along the x-axis, one along the y-axis. If it were three-dimensional motion, you would have to apply the same equations of motion. We are talking about constant acceleration. So you would have to apply the same equations of motion thrice for every particle, one for each and every axis. The exact same thing is happening here. So there is an axis, वहाँ पे थोड़ा सा आसान रहता था क्योंकि एक्स वाई एक्सिस जो थी वो हमारी जब तक इंक्लाइंड प्लेन पे प्रोजेक्टाइल नहीं आया था तब तक हॉरिजॉन्टल वर्टिकल एक्सिस से हमारा काम अच्छे से चल जाता था. यहाँ पे जो एक्सिस होएगी दैट विल बी अलोंग द लाइन ऑफ इम्पैक्ट एंड परपेंडिकुलर टू द लाइन ऑफ इम्पैक्ट. So along the line of impact, you will find out all the initial velocities and you'll apply that formula हमारा जो था V1 prime, V2 prime वाला. But V1, V2, V1 prime, V2 prime are all now components along this line of impact. They are all components of velocity along the line of impact. So you will also take now two axes. One will be along the line of impact and the other will be perpendicular to the line of impact. The velocity components along the line of impact will take part in collision, just as we have been doing up till now. And the velocity components perpendicular to the line of impact will not change. Okay. Let me give you a question on this. A particle strikes a sphere as shown. Find velocity after collision if E is equal to. Assume no gravity. So this is M, this is R, this is 9M, and this distance is an R by 2. Does not look like it, but it is R by 2. ये दोनों M सेम है, मतलब अगर आप एक को स्मॉल ले रहे हो तो दूसरे को भी स्मॉल लेना, एक को कैपिटल ले रहे हो तो दूसरे को कैपिटल. how do you approach problems like this? First, you have to decide the line of impact. After you have decided the line of impact, then you are going to find the components of all velocities parallel and perpendicular to this line of impact. Once you've done that, then you can apply the formulas additionally, of course, external impulsive force 0. Then you can apply all the formulas that you have at your disposal for collisions, but only along that line of impact. Okay? And the perpendicular components, they don't change at all. हाँ मतलब कुछ भी assume कर लो यार, we not assume कर लो. हाँ ऐसे कुछ आना चाहिए मतलब वो So first thing that you have to do is you have to recognize the line of impact. Where is the line of impact? Line of impact. Where is it? Line of impact will be here. Because when the particle strikes, line of impact will be along the normal reaction. So now what you do is you find the components of the velocity along and perpendicular to the line of impact. The sphere is stationary, so we don't have to worry about its velocity components. Right? So we get, let's say this is angle theta, V naught cosine theta, V naught sine theta. Okay. So along the line of impact, I will write down M1 is equal to M. V1 is equal to V naught cosine theta. Please notice that I will only take the velocity component which is along the line of impact for putting in my formula. Right? So V2 is equal to 0, this is given, and E is equal to 1, this is given. I am interested in finding V1 prime and V2 prime. So V1 prime will be M1 minus M2. Line of impact, Pratiksha, is the normal reaction between the two colliding objects. Line of impact is the direction of normal reaction between the two colliding objects. Example number 1. Particle is moving like this with velocity v, collides with the floor. Where is the line of impact? Particle is moving like this. Where is the line of impact? This is the line. Example number 2. Particle is moving with velocity v naught, collides with the wedge. Where is the line of impact? So this will collide here. This must be the line of impact. ये सारे क्वेश्चन हम आई थिंक करेंगे ही, तो just particle is dropped. Where is the line of impact? आया समझ में? दीक्षा? आई थिंक HCV में दिया हुआ है V naught, there is a line of impact. Well, ultimately the sphere is going to collide with the other sphere like this. So this must be the line of impact. Okay, line of impact is nothing but the direction of normal reaction acting on the acting between the colliding particles. So m1 minus m2 divided by m1 plus m2 into v1 and v2 prime will be equal to 2m2 divided by m1 plus m2 into v1. So this will be equal to minus 4 by 5 v naught cos theta, and this will be equal to 18 by 10. 18 by 10 would be 9 by 5. 9 by 5 v. So this guy will move with a velocity of 9 by 5 v naught cosine theta. This guy will have a velocity of 4 by 5 v naught cosine theta. But it already has a velocity of v naught sine theta that is not going anywhere. So the net velocity of this guy will be this. So v net of m will be equal to under root of 16 by 25 v naught square cosine square theta plus v naught square sine square. Now this is very easy to find out because I have considered this as angle theta, so this must be angle theta, and sine theta is equal to half. Therefore, theta is equal to 30 degrees. Okay. So V net is equal to V naught root of 16 by 25 into 3 by 4 plus 1 by 4. And you can find this out. And V of m will simply be 9 by 5 V naught cosine theta, which is root 3 by 2. This is equal to 9 root 3 by 10. नहीं HCB ने ग्रेविटी नहीं दिया है उसमें तो हम, लेकिन HCB ने दो spheres दिए हुए हैं ना of the same size moving on a horizontal smooth surface. उसका इफेक्ट सेम, मतलब ये जो है सेम है. I just did not want to keep it on a horizontal surface, इसलिए मैंने इसको ऐसे. अगर मैं ये बोलता Okay, you should be very very aware of this. अगर मैं ये बोलता that ये पार्टिकल ऐसे स्फीयर ऐसे हॉरिजॉन्टल सरफेस पे रखा है और एक पार्टिकल इसको आके हिट कर रहा है, could I have applied what I have applied right now? अगर ये यहाँ पे सरफेस पे रखा होता, could I have done this? Could I have done this? I could not have done this. Yes, exactly. Yes. क्योंकि जब ये पार्टिकल इसको हिट करेगा, इनके बीच की जो लाइन ऑफ इम्पैक्ट होगी वो तो ये रही। इसका मतलब ये हुआ कि पार्टिकल ने स्फीयर के ऊपर ऐसा इम्पल्सिव लगाया और स्फीयर ने पार्टिकल के ऊपर ऐसा इम्पल्सिव फोर्स लगाया, और ये वाले इम्पल्सिव फोर्स को काउंटर करने के लिए फ्लोर एक इम्पल्सिव फोर्स लगाएगा ऐसे, और ये इम्पल्सिव फोर्स का एक कंपोनेंट इस डायरेक्शन में। So because of this external impulsive force, there will, or there, because of this external impulsive force, we cannot apply the formula v1 prime. Okay, you have to be aware. ऐसा नहीं है कि आपको बस उठा के लगा देना है कि नहीं मैं तो बस हो गया। है जीरो पोटेंशियल लाइन कहाँ से आ गया? जीरो पोटेंशियल लाइन रेफरेंस लाइन होती है जहाँ से पोटेंशियल निकालते हैं, पिछले चैप्टर में किया था। I think I'll stop here. नहीं जा रहा हूँ उससे। Now you can do all of HCV. Please complete it as soon as possible. ठीक है ना? उसमें एक set of problems हैं जो आप try कर, I mean you can try it. It's not that you can't do it, but I will show you a better method to do it later on. There is a series of spring block problems in the chapter. I think there are around 4-5 problems together, one after the other, about springs and blocks, and I will show you how to deal with them. But you can do them. थोड़ा सा आपको लंबा पड़ेगा, but you can do them. So please complete HCV. Next class में we'll talk about हाँ तो zero potential line can be in any direction you want, depending on what is producing the potential. If we are talking about only the gravity of the earth near the surface of the earth, उसके लिए आप जीरो पोटेंशियल लाइन खोज रहे हो, वो हमेशा हॉरिजॉन्टल रहेगी। लेकिन अगर हमारे पास कोई दूसरे टाइप का मास डिस्ट्रीब्यूशन हो गया, फॉर एग्जांपल हमारे पास एक इनफाइनाइट शीट ऑफ मास हो गया, वहाँ पे जो जीरो पोटेंशियल लाइन रहेगी वो पैरेलल टू द शीट रहेगी। जो हम ग्रेविटी में करेंगे वैसे भी। नहीं आर्यन, अभी वेरिएबल मास नहीं, मेरे को एक क्लास और चाहिए इसमें अभी और चीजें बची हुई हैं। वो मैं नेक्स्ट क्लास में डिस्कस करूंगा एंड देन विल डू वेरिएबल मास सिस्टम। ठीक है, उसके बाद क्लास तो नहीं है ना अभी, ये आखिरी था ना?
अच्छा लास्ट
लास्ट था।
चलो ठीक है, आज थोड़ा जल्दी करते हैं। नेक्स्ट क्लास में आयुष अपन ये करेंगे, यही करेंगे, यही कोलिजन्स ही करेंगे। प्लीज कंप्लीट HCV guys, ठीक है ना, बिफोर द नेक्स्ट क्लास ट्राई टू कंप्लीट।